Hey guys, this is the notes for 2.4 on slopes of parallel and perpendicular lines. Okay, so what we're going to do is review these terms. So our slope, right, remember, is our rise over run, which is equal to our change in our y2 minus y1 over x2 minus x1, because it is the change in y, or delta y, over change in x. Okay, and it's also the average rate of change on an interval, which you'll go into for algebra 2. But you should remember rise over run, or y2 minus y1 over x2 minus x1. All right, positive slope is when your slope, or m, is greater than 0, right? And it's when the line rises up and to the right. Okay, and then negative slope is when m is less than 0, the line falls down to the right. So if you have like an xy here, an xy here, right, those are your xy's, right? This is a positive slope. This is a negative slope. Falls down and to the right. Okay, and then the equation of a line, we have two that we can work with. The first one, right, we should remember slope-intercept form. Which is y equals mx plus b, where m is your slope and your b is your y-intercept, where it crosses the y-axis. Okay. Then we have point slope form, right? We have y minus y1 is equal to m times x minus x1, right? And this y1 comes from a given point, x1, y1, right? And then the x1 comes from that given point, right? And then our m is our slope still. All right, let's move on to some examples. All right, so what we can do is graph this line. So we have a slope, m is equal to negative 3/4. So that means either up 3 to the left 4, or down 3 to the right 4. Okay, and then this is our y-intercept. Right, so let's plot our y-intercept. Right, it's going to be at 2, 0. Oh, 0, 2, sorry. 0, 2. Right, that's our y-intercept. And then from that point, we're going to graph a point using the slope. So we can either go up 3 to the left 4, or down 3. 1, 2, 3. To the right, 1, 2, 3, 4. Then we plot the point. Right, so we went down 3 to the right 4. And now make that line. Right, pretty easy. All right, now let's work backwards, right? Let's find the equation of the line. Okay, so this is sort of review stuff. So write the equation of the line, right? We have a y-intercept of 4. So b equals positive 4. And then we need to find the slope. Slope equals rise over run. Right, so let's pick 2 points. So we have here, so it goes up 2, up 4, to the right 2. So 4 over 2, which reduces to 2. So this is our m. So we can plug into our y equals mx plus b form. where we get y equals m is 2 from here, x, and then b is 4, so plus 4 from the y-intercept. And that's our solution. Okay. Now let's practice going through finding a slope between a set of 2 points. All right, so here's our x1, our y1, x2, y2. Our slope formula is slope equals m, which equals y2 minus y1 over x2 minus x1. Okay. All right, so y2 here is 4 minus y1, 2. x2 is 5 minus x1, 2. So we get 2 over 3 equals our slope. Next one. This is x2, y2, x1, y1. Doesn't really matter the order which you pick them, as long as these two are both 1, these two are both 2. All right, so y2 is 1 minus y1, which is negative 2. x2 is 2 minus negative 1. So it becomes 1 plus 2 equals 3, and then 2 plus 1 equals 3. Therefore, our slope is 1. All right. All right, so I skipped over the discuss problem. We're going to jump right into the theorems for this that kind of help us go through these notes. So our theorem 213, right, tells us that two non-vertical lines are parallel if and only if their slopes are parallel. Okay, so any two vertical lines are parallel. So, right, if P and Q are both not vertical, right, then P and Q, right, their slopes are equal. All right, so because they're not up, straight, down, and vertical, their slopes are equal. Right, if they're parallel, then their slopes are equal. For parallel, that's what we're trying to get out of this, right? If they are vertical, straight up and down, right, our slope is equal to undefined, right? So they are parallel. They're both undefined and they're both parallel. All right, the next one says two non-vertical lines are perpendicular if and only if their product of their slopes is negative 1. Okay, a vertical line and a horizontal line are perpendicular to each other. So, right, the second one, right, if one is vertical, right, they are parallel, and one is perpendicular, they are parallel. Perpendicular. So sorry, if they are perpendicular, they're parallel if one is vertical and one is horizontal. Sorry, I confused that. Vertical, horizontal. Now, right, this says that if their products of the slope is 1. So that means if their slopes are opposite reciprocals, then they're perpendicular. Okay, what I mean by opposite reciprocals, right? Reciprocal, right? So say we have an A over B, its reciprocal is B over A, right? Remember, we flip the numerator and denominator essentially. Okay, so, or if you had like 1 over 2, the reciprocal is 2 over 1, right? And then opposite, right? So that's for reciprocal, right? Opposite just means, right, negative. If it's negative, then the other one is positive. And if it's positive, the other one is negative. So opposite signs and their reciprocal fractions, right? You take the reciprocal. So if they're opposite reciprocals, then they're perpendicular. All right, so now in this example, what we're going to do is check parallelism. Okay, what that means is we're going to figure out if K and N are parallel, right? How do we figure out if they're parallel? They are parallel if their slopes are equal. So we need to find the slopes of K and N, and we need to figure out if they're equal, then they are parallel. Okay. So how do we find the slopes? Well, we can pick 2 points on the lines and then do y2 minus y1 over x2 minus x1. All right, so for K, right, so we're finding the slope of K, right? We want to find 2 points. All right, here's a point. We can use, is that -2, 2? And then we can also use -3, 2. I'm sorry. Not -3, 2. Right. Sorry. Yeah, sorry, 2, -3. 2, -3 is a point. So, right, here's our x1, y1, x2, y2. Right, so -3 minus 2 over 2 minus -2. We get -5 over 4 as our slope. Now, the slope of n, right, we need to find 2 points. There's a point here at 1, 2. And then we see another point here at 4, -2. And now we're going to find the slope. Right, here's our x1, y1, x2, y2. So -2 minus 2 over 4 minus 1. We get -4 over 3. Right, so because these are not the same slope, they are not parallel. Okay, if they were both -5/4, then they'd be parallel, or both -4/3. But because they are different, we cannot say they are parallel. We can say they are not parallel. All right, so we're going to do the same thing for J and K. We're going to find their slope, but their slopes need to be opposite reciprocals. To be perpendicular. So one has to be negative, one has to be positive, and one has to be, you flip the numerator to the denominator. All right. So let's find J and K. So slope of J in this problem. So J is here. Find 2 points. Here's 1 point. Here's another point. All right. So slope of J. All right. We'll use the point 1, 2, and use the point 3, -1. So you just got to find the points on here, right? So see how these cross at a certain point? That's why I marked those on J. So we'll use the slope, right? -1 minus 2 over 3 minus 1. So we get -3 over 2. Right, so that's the slope of J. Now this one, right, we need, for these to be perpendicular, K slope has to be the opposite, so positive, and then flip the numerator to denominator, so it has to be 2/3. So let's solve for the slope of K. All right, so the slope of K starts by finding 2 points. So we have a point here. And then it looks like we have a point here crossing at 0, 4. Okay, so we have -3, 2, and 0, comma 4. So x1, y1, x2, y2. All right, remember y2 minus y1 over x2 minus x1 equals our slope. So 4 minus 2, and then 0 minus -3. We get 2 over +3 as our slope. And right, these are opposite reciprocals. So J and sorry. And K are perpendicular. All right, now the last part. So the first 2 parts are finding whether 2 lines are parallel by finding their slopes, or finding if they're perpendicular by finding their slopes, if they're opposite reciprocals, parallel if they're the same. Now we're going to go through how to write an equation given a line and given a point on a parallel line to it. And then next we'll be given a point on a perpendicular line to it and figure out how to find the equation of that line. All right, so what we need to do is we need to find the equation of the line through P that is parallel to line L. Okay, so we're going to follow these certain steps. There's 3 steps, and that will help us solve for this equation of our new line that goes through P and is parallel to L. Okay, so we need to first find the slope. We use the slope from line L because they are the same, because they are parallel. So our slope is 1/2. We know when lines are parallel, their slopes are equal, or they're the same slope. Right, so our slope is 1/2. Now we need to solve for the y-intercept, which is our b, and we're going to substitute in the slope and the given point P into our equation y equals mx plus b. So our m is 1/2. Our xy from our point P is 4, 1. Right, again, that's point P because that's the point we're going through with this line. So we have y equals mx plus b. We're going to substitute in the slope, right, and the 4 and the 1 for xy, and we're going to solve for b, which is our y-intercept. So we get 1 for y equals 1/2 because of m. Our x is 4, and then plus b because we're solving for b. Then we clean it up. All right, we get 1 equals 2 plus b because 1/2 times 4. Subtract the 2 to both sides, and we get -1 equals b. Now to write the equation, right, what we need to do is substitute in our m and our b into the y equals mx plus b equation. So we get y equals 1/2 times x, and then it's -1 for our b. And that is the equation of the line parallel to line L that goes through point P. All right, now we're going to do something very similar, except for we're going to find the line parallel to L that goes through our point P. Okay, so when sorry, not parallel, perpendicular. So when it's perpendicular, remember our slope is opposite reciprocal. So it has a different sign, and then we flip our numerator and denominator. So if our slope for our original L is 1/2, so L slope 1/2, then the slope of our new line perpendicular, right, is opposite, so it's negative, and then we flip our 1 and 2, right, so it becomes 2 over 1, or our slope is negative 2. Okay, so we need to use this negative 2, and we need to solve for the y-intercept. So our slope is negative 2 for the line perpendicular to L. We're going to use our point P, which is 4, 1, as our x and our y, and we're going to solve for B. So y equals mx plus b. Our y is 1 again. Our slope is negative 2. Our x is 4. And then we're solving for b. We get negative 8 for negative 2 times 4. Add the 8 to both sides. We get 9 equals b. So now we need to substitute in our b and our m into y equals mx plus b. So y equals m is negative 2 times x plus 9. And this is the line perpendicular to L that goes through point 4, 1. All right, so for now, you're going to try this A problem and B problem, and then I'll post this. I'll pull up the solutions and then go through it. So pause it now. You'll see A, and then you'll also see B, where you need to try A and B on your own, and then I'm going to pull up the solution. So pause it now, try them on your own. Okay, so here's the solutions. For A, right, your slope is negative 3, so you need to have the same for the parallel. Perpendicular is opposite reciprocal. So, right, same for parallel, it's 3. Negative 3. Opposite reciprocal is positive, and then instead of 3 over 1, it's 1 over 3. So then you substitute in the points 3 for x and 1 for y into both equations, right, with the new slopes, and then solve for b, and then you get your solution. Same thing for b, right? Your slope is 3/4, so parallel is the same. Opposite reciprocal is negative 4 over 3. Then you substitute in this for x, this for y. All right, those are your x and y's that you substitute in, and you got to solve for b. All right, and then once you solve for b, you just substitute in m and b into y equals mx plus b, and that's how we get our solutions for all of these.